In this video, we are going to be discussing the topics in chapter 4, which is titled Atoms and Elements. The first thing that we need to discuss is the elements in the periodic table and their symbols. We previously discussed that pure substances can be divided into elements and compounds. Where can we find elements? In the periodic table. Understand that elements, their basic definition is that they are pure substances from which all things are built from. So everything that you have surrounding you at this moment is being built by elements combining with one another, or on instances they are going to be found on pure form. Understand that elements cannot be broken down into simpler substances, and they are listed on the inside front cover of the textbook. Now, understand that this edition of the textbook does not have all the elements from the periodic table, and at this time the periodic table actually has 118 elements are known to date. Now, understand that all of these elements that we have in the periodic table, and we know not everything is found in nature. Now, if we look at the periodic table that we have on this slide, you can see that if we zoom in on it, and I'm just selecting an area, we have actual samples of each of the elements in their pure form. Now, understand that there's going to be times in which you observe, like if we focus on element 104, 105, all the way down to 118, even though not everything is incorporated, you may see that what we have is images, okay? And it's not because those are specifically the people that created them. These are images of the people that the name of that element came from. So, as you can see, elements have different colors, they have different shapes, and this is just illustrating how they actually look like. Now, understand that when it comes to elements and their names, the names can come from a variety of resources, including planets, mythological figures, minerals, colors, geographic locations, and famous people. As I just illustrated previously, it's illustrating to you guys the ones that actually have an image. Now, as you can see in table 4.1 in the textbook, there are a few examples of elements and where did their name come from. But I think the most important thing is that from the reference list that it is included on Canvas for the course, you must memorize the list of elements that are there. Those are the ones that we're going to most commonly utilize in the course, but you should know what is their name with the correct spelling and their symbol with the correct spelling. So please make sure that you check out that list that it is included in the Canvas site for the course. Now, when it comes to the element symbols themselves, remember that the chemical symbol is going to represent the name of an element. Now, symbols can have one letter or they can have two letters. Okay? Now, understand that chemical symbols will always consist of a capital letter if they only have one. If the element has two letters, it's going to be a capital letter followed by a small case letter. So for example, here we have a sample of different elements that have two letters: cobalt, calcium, aluminum, and magnesium. Please make sure that you notice how they are properly written, because I don't want you guys to be losing points just because you decided to give it a different notation to the element symbol. These are the set rules of how we write element symbols, so learn how to write them correctly. Now, Let's now discuss more in depth the periodic table and the information that we can find in the periodic table. So understand that the periodic table that you see to the left of this slide represents the 118 elements that we know to date, okay? And understand that the periodic table currently organizes those 118 elements into groups that contain similar properties and places them in order of increasing atomic number. So that's how it's organized now. The first person that organized the periodic table or initiated the organization of the periodic table is Dmitry Mendeleev, and you can see his image to the right. He was the Russian scientist that, again, developed the first classification for the elements, but during that time, because the number was limited, he actually ordered them in terms of increasing atomic weight. Okay? Now understand that this way of organization is no longer utilized, and the way that we organize it currently is based on increasing atomic number. So as I mentioned previously, the elements in the periodic table are organized in groups, but in addition, they're also organized in periods. So understand that groups are going to be the vertical columns for the periodic table. And all of the elements that are within a group, or I should say the majority, because there's always exceptions to the rules, the majority of the elements that are within a group are going to have similar properties. Okay. When it comes to periods, understand that periods are going to be the horizontal rows where the elements are. And currently, for the organized periodic table that we utilize, there's only periods 1 through 7 in the periodic table. So when it comes to group number, understand that they are going to be at the top of each vertical column. And we're going to have two separate groups, if we want to think about it that way. Anywhere where we see a group, and I'm just going to highlight it in orange, anytime that we see a group that has a number in the letter A, that is known as a representative element. Okay? Whenever we have, and I'm going to highlight it in blue, a number with the letter B, that is known as a transition element. Now, the periodic table that I provide to you guys, and it is already posted on Canvas, has numbers and letters. Understand that maybe you have at home a different periodic table, and there is an alternative system in which the group numbers are assigned by a number only, and the periodic table columns or the groups are numbered from 1 to 18. Okay, from left to right. Understand that both systems are utilized, but the one that I will be most commonly using in class is the numbers and letters. Now, when it comes to the groups, understand that there are a selected columns or selected groups in the periodic table that have a particular name. Okay, and I'm going to highlight those in yellow. So group 1 or 1A, 2 or 2A, 17 or 7A, 18 or 8A, and group B, which extends through the middle where these gray boxes are. Those are the 5 groups in the periodic table that have a particular name. Group 1A is known as the alkali metals. Group 2A are the alkaline earth metals. Group 2B or Group B are the transition elements. Group 7A are the halogens. Group 8A are going to be the noble gases. And again, because we're talking about a group, the group establishes that that is going to be the column that we have in the periodic table. Understand that elements can also be classified as, based on their physical properties as metals, non-metals, metalloids. Okay. Some of the properties are also chemical properties, but I just wanted to establish that metals are going to have certain properties that are in common, that many of them are going to have. Non-metal are going to be separated, and then metalloids are going to be their own group. As you can see here, the metals are going to be around 70% of the periodic table. So the majority of the elements are metals. The metalloids, where you can find them in these green boxes, is a group of elements that you should memorize. And the reason why I suggest that you should memorize them is because when you're trying to define, okay, is this element a metal or non-metal or a metalloid? If you memorize the metalloids, as I am suggesting, then you can say the non-metals are going to be to the right of the metalloids. That's where we find the non-metals. And then to the left of the metalloids, that's where we're going to find all our metals. Now, understand that there's only one non-metal, that it is to the left of the metalloids, and that's going to be hydrogen. Okay? Hydrogen is the only one that is here in group 1A that is actually a non-metal, because some of the properties that hydrogen has. So as long as you know what where the metalloids are, it's really easy to identify which elements are non-metals, which elements are metals. Now, each one of these characteristics, when it comes to the metals, meaning if they're metal, non-metal, or they are metalloids, they have some common characteristics between all of them. So one of the things is that metals tend to be shiny, and they're actually ductile. Ductile means that they can be molded into wires. Okay, that's what ductile means. Now, metals generally, they are good conductors of heat and electricity. Okay. Now, when it comes to non-metals, they tend to be dull and brittle, and they're actually poor conductors, but they are good insulators. Metalloids, on the other hand, are better conductors than non-metals, but not as good as metals, and they are utilized as semiconductors and insulators. Now, understand that metalloids are very special. They're a group on their own, because it's not that a metalloid has half of the properties of a metal and half of the properties of a non-metal. No. Some metalloids have certain properties that kind of look like metals, but they are not. Okay? Just because they are not going to be sharing all the properties. So understand that this is a class by themselves. It's not a combination of the previous two types of elements that I discussed. Now, understand that when it comes to the elements in the periodic table, here there is a problem from the worksheet that we have for the class, in which you're going to have a particular element and you're going to classify it as a metal, non-metal, and metalloid. So let me just write down a few elements, and then we are going to determine if they're metal, non-metal, or metalloid. So let's deal with sodium. Let's do nitrogen. And let's do silicon. Okay? So, when it comes to this, understand that sodium is actually a metal, and its group number is going to be 1A. Because it is 1A, if we look at the name, as you can see, that's an alkali metal. Out of group 1A. Then we have nitrogen. Nitrogen is actually a non-metal. If we look at the periodic table, nitrogen is in group 5A. And if we look at the name for the groups, understand that group 5A doesn't have a common name. So there's not a common name for nitrogen. Okay? So you don't have to write anything as a common name for it. This is just to relate some of the concepts that we did previously. And lastly, we have silicon. If we look at our list, as you can see, element 14 is silicon, and it is a metalloid. And it lives on group 4A. And understand that in group 4A, it actually does not have a common name, so we don't have a common name for that. Okay? So make sure that if you have the element name, you can determine if it's a metal, non-metal, or metalloid, and what is the group number for that element.